NU contains 4 red balls, 7 black balls, and 3 green balls. So it contains 14 balls. We need to choose 3 balls out of them, one after another without replacement. This means successively without replacement. So in fact, we have 14 balls and we need to select 3 balls out of them successively without replacement. The first part asks about the number of different ways of selecting these balls. So we're going to have 14 times 13 times 12, which is 21, 84 different ways. We are applying the result of activities 1A and 1B. Now we're going to go deeply in how many different ways can these balls be selected if they have the same color. Now we have here a certain condition that should be satisfied. The condition states that the selected balls should have the same color. Let's see how do we do it. The first could be red, the second red, the third red, or the first could be a black, the second is a black, and the third is a black, or the first could be green, the second could be green, and the third could be green. Remember, even though we are choosing from the 14 balls, here specifically we need the ball to be red, for example, to be black, to be green, so we have a certain condition. We use the same way of thinking, the same strategy to answer this question, but here we have to pay attention that the total will be different. So in the first case, the total of red balls is 4. It's not going to be 14 anymore. So to choose one red ball out of 4, this would be 4. Then we put it aside, we choose another one. We're going to have 3, then we have 2. And OR is going to be represented by this plus. Now black, we have 7 black, so it becomes 7, 6, 5. And this OR would be also represented by a plus. And then a green, we have 3 green balls, so we get here 3 times 2 times 1. So we use the same previous way, which is the arrangement way, but here we have to pay attention to the total of each subset. So we're going to have 240 different ways. Let's apply more. In how many different ways can these balls be selected if exactly one red ball among the 3 selected balls is selected? So we're going to choose 3 balls, but we need exactly one red ball among them. So having one red ball only means that we're going to have 2 balls which are not red. So this is the way we write it by. So the first ball could be red, so the second one should be non-red, and the third one should be non-red. And this bar means none or not. Or we might have another way. The first ball should be non-red, so the second should be red, and the third should be non-red. Or we're going to have the first ball is non-red, the second ball is non-red, and the third ball is red. Now, how do we answer such a question? Let's begin. The first one is red, so we are choosing one ball out of 4. This is 4. The second one should be non-red, so we try to divide here the sample into 2 groups, the groups of red and the groups of non-red. In fact, we have 4 red and 10 non-red. So here we will have 10 and then we will have 9. Remember, it decreases by 1 because we are choosing the balls successively without replacement. Now OR, this is OR, which is a plus. The first ball could be non-red, so 10. The second one is red, which is 4. And the third is non-red, which is 9. And similarly for the third case. And this would be nothing but 360 plus 360 plus 360. And we all know the relation between addition and multiplication. So 360 plus 360 plus 360 is nothing but 3 times 360, which is 1080 different ways. And here, in fact, we could have found only one of these 3 cases and then multiplied it by 3. This is what will happen here. Remember, in order to get exactly one red ball among the three selected balls. So the first could be red, the second should be non-red, and the third should be non-red. And here we multiply by the order. Now the order of what? The order of such case. Remember here we have three different letters, and two letters are repeated twice. So here we have 4 multiplied by 10, which is the number of non-red, multiplied by 9, which is also the number of non-red, and we multiplied it by 3 factorial over 2 factorial. This is a 3-letter word, 3 factorial. 2 letters are repeated. This is 2 factorial. And we get 360 times 3, which is 1080. Now, in fact, I prefer the second way, which is here, because sometimes we're going to have 6 or 7 or 10 or I don't know 100 different cases, so we cannot always repeat them. That's why it's better to take only one case and then multiply by the order. And this is what we meant by the order is important in a successive drawing. Let's continue with this application. A school has 120 boys and 80 girls. 4 students are to be selected randomly and successively without replacement. In how many different ways can these students be selected? Try to do it alone, but remember here that we have 200 students and we need to choose 4 out of them randomly, successively without replacement. Try to do it alone. So here we have 200, 199, 198, 197, which is this very huge number, or we could have used the arrangement. Now, in how many different ways can these students be selected if they have the same gender? Try also to do it alone. Well, in this case, we're going to have boy, 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 or girl, 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 girl. Now the selection will not be done from the 200 students, but we're going to take the first selection from 120 because they should be selected from the boys, and in the second case we're going to select it from 80. So we're going to have 120 times 119, 118, 117, and this all is translated into a plus, and then girls 80, 79, 78, 77, and this would be the number of different ways. Now one might ask, why don't we use the order here? Remember, the order of such a word, which is B, 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 is going to be 4 factorial over 4 factorial, and 4 factorial over 4 factorial is 1, and the product by 1 doesn't change the result. So whenever we have a successive drawing without replacement, the order is going to be very important, but specifically when we have the same letters like this case or this one, we're going to see that we will ignore the order. Now the third case, in how many different ways can these students be selected if exactly 2 boys among the 4 selected students are selected? So we need exactly 2 boys. If we have exactly 2 boys, this means that we have also exactly 2 girls. Try to do it alone. Well, we're going to have boy, boy. These are 2 boys. So girl, girl. We're going to have 2 boys and 2 girls, and we multiply by the order instead of stating all the different cases. So a boy is selected in 120 ways, then another boy 119, a girl 80, another girl is 79, times the order of such a word. It's a word that contains 4 letters, so we have 4 factorial. B is repeated twice, we get 2 factorial, and the G is repeated twice, we get also 2 factorial. And this would be the answer. Now let's see the last case. In how many different ways can these students be selected if at least 3 boys among the 4 selected students are selected? So we need here at least 3 boys. So we need 3 boys and 1 girl or 4 boys. This is the meaning of at least 3. Try also to do it alone. Remember, we have two cases. Well, at least three boys, so we're going to have boy, 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 girl times order, or four boys, which is B, 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 B. Again and again, we're not putting here the order because the order of such a word is 1. Now, to choose a boy, we have 120 ways, then 119, 118. To choose a girl, we have 80 different ways. So we multiply by the order of such a word, which is 4 factorial over 3 factorial, or is translated into a plus. And here 4 boys, so this is what we have, and this would be the final answer.